Hello everybody, welcome to class CS202 online. Fourth class, but video 3, since we had the syllabus, that's the first video. That would be video 0, since we start counting from 0 because we're computer scientists, right? So today we're gonna keep talking about classes, and we are going to introduce this concept of the universal modeling language, which is more commonly known as UML diagrams. And then from there, we're going to just keep talking about classes and see how far we get. But today is all about classes. If we get it far enough, we'll talk about inheritance. But I don't think we will. So we will see. Hope you guys are all doing good today. And next class is on Tuesday. But since I do the recordings on Monday, and Monday is Labor Day, I can't live stream it technically because it's a holiday. So I will probably just record it and then post it. So there will be no live stream on Monday for this class. Yes, it's weird, but that's kind of what I have to do. So yeah. Okay. So last time I went ahead and copied and pasted the code, and I will upload this code later today to the Canvas thing. So this is the code from last class. I just put it in a different file so that I could leave the other one unmodified for you guys to play with, and then we'll start off with this one. And so basically let's kind of see what we were doing here. We had a class A, and I had a function, and I was talking about scoping rules and how the local variable inside of foo is different than the class variable into x, right? So those are totally different variables. They're able to share the same name because they're in different scopes. If you try to make two variables in C++ with the same name, that's when you run into problems. This time, no, the microphone is like right off the camera. It's right here. So I don't know. This time you just have to raise the volume, I guess. I mean, it is coming out from here, right? Let me see. Yeah, it's coming out of there. Just want to make sure it wasn't coming out the webcam. Yes, buy better speakers. You'd probably be a better Warzone player if you could hear other people better. So anyway, essentially, I just want to nail that point to the ground about scoping. That if I was to go ahead and put in here int x, this is still okay. This is a perfectly legal code. However, now the x here is going to be referring to this x and not to the class variable. In fact, now you should be asking yourself, what if I wanted to access the class variable? Well, there's a couple of ways to do that. There's using something known as a dis pointer, which we'll talk about at some point when we talk about pointers and stuff, virtuals, that kind of stuff. We can come back to talk about a dis pointer. But another way I believe will work is if you put the name of the class and then the scope resolution operator, which is the 2 colons. You might not know what the scope resolution operator is, by the way, but voila, this is the scope resolution operator. And what it does is it allows you to reference an object or a variable from a different scope. I think that's the official terminology of it. What it means in practice is it allows you to access variables from specific classes. And when we talk about static variables, we'll kind of nail us to the reason as to why that's useful. But the most commonly used version of that is if you try to define these functions outside of the class. So for now, let's just go ahead and test to make sure that I do remember my C++ correctly. Let's just see if that will actually output 5 here. Okay. So and then here, let's do 2 actually. Let's do 2. Let's do CA X end line and then A. So this one should output 5, and this one should output 10, I think, or 20, whatever is in X. I think it's 20, something of that sort. So we'll see. Class 2. Oh, did I break the other code? I might have broken the old program code. Let me fix that so I don't send you guys broken code. This should be the exact same code as we just had here. So what is wrong with this code? A has no member Z. That is true. Who knows where that came from? I just comment that out. Okay, that works now. So, okay, that one is fine. So now let's go ahead and go to 3. Okay, so now that one is working. So you guys have good code on that one. And then I'm assuming that this one I have to remove the same line as well. Okay, so let's try to compile this second one. So G++ class 2. And then this one, oh, Coit. You know, I was wondering when you wrote that, Coit. I was like, I don't know if that's like a meme or something. And I kind of just ignored it. But now I see what you were talking about. Okay. So there we go. Which one? There's so many things being outputted here that I think we need to have some other flag. Something I found out, by the way, from a fellow student of yours is a lot of you might not know what flush is. So might as well go over that very fast. So here, for now, let's just say inside of bar. And then let's say that we want to output X. And suppose that we wanted to make sure that X gets printed out right there and then. You can use flush. You could also use endline, but what is flush and what is endline? Okay, what endline does is it adds a line feed to your program, okay? So when you're outputting something, it adds a line feed, but it does another thing. Because you can't just do your own version of a line feed by putting in like a \n. That will indeed create a line feed. The difference between that and the endline is that the endline also flushes the output out, which flush does as well. So technically speaking, a true endline is the same thing as doing \n and also doing a flush. Technically speaking, while I work with the double quotes, the true accurate endline would be to have single quotes. So this is the exact same thing as an endline, okay? But so what is flush? As I said, it flushes the output. Now let me kind of give you a little bit of an explanation about that. Basically, think of it this way. And this you'll learn more in 219, but for now, whenever you say to the computer to print something, you say cout and then you send the message. The computer is very lazy. Okay? The operating system is very lazy. It's like, oh, you want me to print this? Okay, I'll get to it at some point, but I'm kind of busy right now, so just, you know, get in the back of the line kind of thing. And so there's two sort of ways of approaching this problem. Option one is you can sit there and like in DMB and just kind of wait for your turn and then get it printed out and then keep going. Or, like the DMB does nowadays, or at least pre-corona times, is you get a number and you associate your cell phone. And then you can go and do other things. And then when your turn comes, you can come back and do your business at the DMB, right? But in the meantime, the extra hour or so that you would have been otherwise sitting there waiting for your turn, you can now go and do some errands, okay? Like, I don't know, go grocery shopping. Well, no, because I was pulling the car. But go to Best Buy or I don't know, go get gas and wash your car. Yeah, okay? And so those are the sort of two mentalities of approaching this. Because printing takes a long time because of I/O, there is what are known as interrupts. That is how this is actually handled internally. But for now, let me just think of it this way. Option one is you can just tell the computer to print and then keep running code that you can still run that is not connected to that print statement, which there shouldn't be anything unless there's another print statement. Or, you know, if there was a read in, that's different. But for printing, it's not as mission critical to print it exactly when you tell it to print. So like, you know, if I have a cout here, and then I have a function that is doing some math, then that math can happen and it's not going to affect the cout. And so, you know, that's good because you can work faster because the I/O is so slow that you lose computer processing time. So instead, you're just like, okay, go do the output, you know, get it done at some point. I'm going to keep running my program. And it's good. It actually speeds up your program a lot. We're talking like milliseconds versus like nanoseconds, okay? So milliseconds is like potentially how slow your program would run if you have to wait for every single output to get printed versus nanoseconds, which is a lot faster, okay? By factors of like hundreds and thousands, okay? And so essentially, the one downside to this issue is if you're running in this like system of like, you know, telling the computer to do something and then you go do something else. Imagine that like you go to the DMB, And then the DMB keeps track of your state, like if you're alive and still waiting for your turn, okay? But suppose you go to the DMB, you get your ticket, and then you're gonna go wash your car, and you're crossing the road, and you get hit by a car and die, okay? At that point, that will be the equivalent of literally a crash, because you literally just got crashed by a car, okay? So that's a segmentation fault. So in that case, the operating system is like, well, he's gone now, so there's no point in doing what he told me to do, because at this point he's gone, so like, who cares if I don't do it? He's gone. So it throws it away and it never gets printed out. This is a problem because suppose that you as a programmer, every time you're running your program, you're getting run over. You want to find out where you're getting crashed, right? You want to find out where your crash is. But what do you typically do as a entry-level programmer? You put a bunch of print statements, right? The idea like I am here, 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 here. And you count which of the print statements actually get printed out and which don't. And then you sort of try to find out where you crash. The problem is this, because the operating system is lazy, you may have actually reached like your third print statement, okay? But because the operating system was lazy, it never got to printing that. Or sometimes it might even print it and sometimes it might not, which might be even more confusing when you're trying to debug, because you're like, sometimes I get to this line of code, sometimes I don't. What is happening? More than likely, this is what's happening. And so the solution to this is the end line or flush. What that means is like you ask the operating system to do something, and then you sit there and you stand there staring at the operating system. You're like, I'm not going anywhere until you get done. So it is a halting operation. You tell it to do something and you stop your program, you literally stop the program and you wait. Obviously it slows down your program, but the advantage of that is that you guarantee that before you get to the next line of code, you will have finished that print statement. So in the case of debugging by print statements, you want that to happen because you want to make sure that if you got to a certain line of code, you want to make sure that gets printed before it keeps going and potentially crashes. Okay? So yes, and my driving is amazing. All right, but yes. Okay, so essentially when you do a flush, it just says print this out and then wait. Or when you do an end line, it says print this out, do a line feed and wait. So typically we all like to use end line. That's the one that I personally sometimes use. But sometimes if you don't want to have an extra line feed, because there could be a billion of them, you can just use flush. And then, of course, if you're using flush, don't do this because what's the point? But if you do that, then you can print a bunch of stuff in the same line, but you guarantee that after each one, you will wait. Now be careful. Putting a lot of end line or flushes will slow down your program. Obviously, in such a small thing, it doesn't matter. But when you start printing out a lot of stuff, like in a loop, like thousands of items or something, each of those end lines is going to potentially slow things down. And by the way, other thing I have seen happen before, I can't really remember the details, is things can't print out of order if you don't do a flush. Like that, I'm not exactly sure as to why it happens, but it can happen, even if you're not multi-threading. Like I have seen programs that will print things out of order, okay? So flush is important and end line is important, and it's good to know both of them as well, okay? Especially if you see it in other code or in like my skeleton code potentially, okay? So it's a little bit on the side, but as I said, I did hear from somebody that didn't know it. So that means that most of you probably don't know it because that's kind of the extrapolation, that if somebody asks a question, other people have it. So thought it would be worth taking the time to answer that question, okay? So yes, all right, so back to this. We went ahead and put an inside of bar, and then we do the little flush thing, and then maybe want to put a space between them, and then that, okay? So run it again, and this time we get inside of bar 520. So as you can see, this X is referring to the local variable X here, and the 20, which is using the scope resolution operator, is referring to the class variable. So while I don't recommend you name local variables the same way that you would name your class variables, like that just seems very confusing intentionally, know that if such a situation arises, you can work around that by using the scope resolution operator. Okay, as the last thing, let's go ahead and move the bar function outside of the class. This is known as an inline function right now because you are actually defining the function inside of the class definition, which is this whole thing. It is possible to put like a function prototype inside of your class, which would be your class declaration, your function declaration inside of your class, and then to put the body of the function or the definition outside of the class. And it's actually better because it makes your code look nicer. And also when you start talking about multi-file compilation, like you're doing multiple files for all of your code, you typically want to have your class in one file and all of your function definitions in another file, like you have header files and things like that. So because of that reason, it's good to do that now. So let's go ahead and take that code out. So actually, what we're going to do is I'm going to copy that, and now I'm going to delete this, and I'm just going to leave a semicolon there. So that is a little function prototype that we would call a function declaration, okay? And it's inside our class declaration. That's all we need. Somewhere else, like here beneath, we can now go ahead and define that function. And the way we do that is first we put the return type, then we put the class that it belongs to, so A, the scope resolution operator, which is the other big usage of it, which is what I'm showing you right now, and then the function name, then your function parameters, if any, which in this case there's none, and then your curly brackets to specify the body. And in this case now I'm going to paste the code of the inside of the function. And then just press Shift Tab to tab things backwards. You know, you press Tab, it tabs them forward. Shift Tab typically will tab them backwards, or depending on whatever IDE or editor you're using, it might be a different shortcut, but I think that's a pretty universal one. So yes, fancy. Okay, and that's going to be the exact same as if it was in here. At least when you run it, it'll look the same. Technically, there's a little bit of a difference, because inline functions work a little bit different than these kind of functions, in the sense that I do believe that every time, to make the code more efficient, inline functions, you actually, it's like you're hard coding every single call in the code instead of it being a function call. So it's a little bit different in practice, but don't worry about that. I'm sure they'll talk about that in 226 and into analyzing those kind of things. At this point, just know that it's the same, but that this is nicer and better. And you should always really use this for big functions. For tiny functions, inline functions are okay. But this is a much better way. It's much more organized and clean. Let's go ahead and do that with foo as well. So void, because it's a void function. The class name, scope resolution operator, which is 2 colons. The function name, the parameter list, which in this case is int x equal to 0. And then our body of the code, which are these 2 lines. Okay, now in this one's a little bit trickier, because I always screw this up. Because as a default parameter, I don't think this will compile and run. You have to actually go ahead and remove the default parameter. Just leave it like that. And there you go. Okay, I mean, you can, I believe you can put in the variable names. That's okay. It's not ideal because you kind of limit yourself to the variable names and it can be distracting. But what you cannot do is put the default parameter. I believe that will not compile. It will complain. But hey, maybe I'm wrong. Yeah, no, I am right. Okay, cool. So that just happens with default parameters because they're kind of a weird, special thing. So yeah, that's the scope resolution operator. So anyways, that's kind of where we were last time. And so we were trying to introduce the idea of like this whole, you know, we don't want everybody to touch our code because they might break it. And I gave you the really long example about cars and how so you don't have access to the internals of your the computer of your car because they don't want you to tweak it and accidentally break it, right? Put a negative number in some like variable inside. Imagine you could literally recompile the code in your car, and then somebody goes in there who has no idea what's happening and deletes. If man is in C++ and deletes a semicolon, well, now it doesn't even compile. But even if it does, like put a negative value somewhere that you're supposed to have like positive value, or put a 0, and next thing you know, you got division by 0, and the whole thing crashes. And by crashing a computer in a car, it means you're probably going to crash in practice. So, you know, we don't want people to break things they shouldn't break. And it's, of course, we're not going to stop from people who can hack into it. We're just doing the honest man's protection. We're trying to stop people from accidentally doing things they shouldn't, right? We are basically protecting it from accidents, not from intentional misusage, okay? And so to better represent how private and public work, I'm going to give you the other example that I gave last time that I did the class, and that's the little bucket example, okay? So far, and this also kind of nails us to the why classes are useful. So far, you've been coding, if you know 135 with functions, right? And your functions were global functions essentially, because you could access them from anywhere in your program beneath when you declare them, right? And so here's the thing about that. Suppose that you were doing a program to compute the area of a triangle or a rectangle, okay? In these cases, you know, you had a function called area, and then you had maybe like a length and a height, you know, if you're doing a triangle, or length times width if you're doing a rectangle. And then you pass those in, you did a computation, and then you return it. It was a value returning function, right? So you could have done something like that. You could have done something like, you know, int area, and then you take a length and a height, you know. And the problem is, you gotta be more specific, because if this was the area of a rectangle, then we know that this should be return length times height times 1/2, right? I guess if we're doing code, then these should be asterisks, right? So that would actually return to you the area of a rectangle, or sorry, triangle. If we wanted to do the rectangle, that's just return length times width. You could call it height, but let's call it width. I cannot do a W. There we go. Problem though, these two functions have the same name and they're global, and they're super easy to confuse. So now you gotta either change the function name and call this like area T for triangle and area L for rect, or R for rectangle. But it's kind of bad and kind of unorganized, and anybody can access these functions, which is a bit of an issue, which is you can't even make variables called area T if you wanted to. And so it's not good practice to make a mess of the global scope of things by putting all these global functions that are all over the place and anybody can access them. And it's like imagine that you have a common area in the university, and then you just all of a sudden decide that you're going to put this tool for everybody to use, but it's a tool specifically for carpenters, and it's taking a bunch of space because there's like a table saw. And then the people that are like in CS are like, why do I need a table saw for? Like, this space is common. I need the space to like put a server and then like do things. But then you put a server there, and now someone comes in from like entertainment engineering, and they're like, well, I need to put like an RC like control station or something. And so it hogs the space and it's annoying. Instead, it's better to do things in classes, because think about it this way. Imagine that you have a bucket, and this bucket is going to contain not just the data that you're working with, but the operations on the data as well. So you're going to keep both the length and the width, but also the area function, okay? And so now you carry everything together in this bucket, and it's very portable, just like a bucket is. This has a lot of advantages, because now you don't have all over the place like some variable L in the global scope, or even in main, which is you're passing in here, but also you prevent accidents from people trying to call the wrong function. Like some you know, like someone from entertainment engineering, or worse, yeah, someone from computer science trying to use the table saw as a server or something, and then they like cut their hand off or something. So we want to make sure no accidents happen, right? And so the bucket is going to allow you to contain all the operations and the data. And that's a very convenient thing, because then you can easily transfer it over around. So here's the other thing. You know, you got a function, and that function might have like 50 different parameters, right? And that's a pain. You know, you have to write 50 different parameters. It's just a pain. Like, imagine you're trying to compute the area of like a very complicated geometric shape that requires a lot of dimensions to successfully compute the area. That's a pain to have to keep track of that. Plus, like, even here, these are both integers. So you have to make sure you know that the first integer is the length, and the other one, I mean, it doesn't really matter actually for either of these, technically speaking. But, you know, there are some formulas where it might matter, okay? as to which is which. Because here you could do the L could be the W and the W could be the L. It doesn't matter because of multiplication, the math properties. But there are some functions where it would matter. And so you got to keep track of the order of the parameters for that reason. With classes, you don't need to pass any parameters to your functions. Or if you do, there's very few because the majority are already class variables. And the cool and powerful thing about class variables is that class functions can access them without having to pass it as a parameter. It's within that sort of it's like a mini global scope inside. That is why in the example I was showing you earlier, the X right here, which here, let's just get rid of this X for now. Because I mean, even though this is nice, I mean, it's not a lot of writing, it can be simplified even further if you don't have any local variables with the same name, which, as I said, really shouldn't. So then this line of code right here will access you the class variables. So you could have a billion different class variables here, and you would be able to easily access them without having to pass them as parameters here. And that is a big saving in terms of space and time in terms of coding. On the other hand, in general, structs just allow you to keep and sort of contain a bunch of different data types. They don't have to be built in, because one thing we'll learn is you can have a class, and then inside of it, instead of having an int x, I could have another class in there. I could have a class B that is living inside of class A. Now, I can't have another class A inside because that's like inception, and it just goes in circles. You can do that with a pointer. That's kind of how linked lists work, but not just like an actual one, okay? And so, essentially, classes are going to allow you, and structs as well, because I said structs and classes are basically the same thing. They're going to allow you to more easily send data, process data, and do those operations, okay? So that's sort of the why object-oriented programming, which is what this really is so popular in today's development world. The reason why it's called object-oriented programming is because whenever you instantiate a class, the class is like the blueprint, okay? So class A, this code right here, is a blueprint. And when you instantiate an object of this class, you're making an object, you're instantiating the class, you're creating an object, you're instantiating an object. These are all same terms for the same thing. You're making an actual object. What is an object here? The lowercase a is an object. So when the name object-oriented programming comes along, you're saying that your programming is focused on making objects and having them interact. Okay? So that's where that name comes from. All making classes. Go to languages like Java or C# and everything is objects. Like, you don't even want to have something that's not an object. In fact, there are no global variables in C#. If you want to use one, you're going to have to make it public static, and this kind of gets around that. But even that is a class. So yeah, that's kind of the origin of that name. So I just wanted to make sure that we understand as to the motivation for using classes. And I suppose I should define what a class is by definition, I suppose. A class is a collection of a fixed number of components. Here, actually, I might just be able to copy paste that from here. Nope, can't do. So yesterday, the whole thing froze when I tried to do it. So this time I'm not gonna try to do it. So collection of a fixed number of components. Okay, and then an object, as I said, is basically an instance of a class. Okay, so our class is easier to deal with coding wise than like structs or vectors. Classes and structs are the same thing in C++. The only difference is that classes are by default private and structs are by default public. Something that you can very easily change with one line of code, with a modifier, which we did actually here. We wrote public. Again, we still gotta delve deeper into this whole public and private thing, but I'll show you an example in just a second. Vectors are arrays, but you can't really have functions unless you do function pointer array, which don't do that. You can't really have functions instead of arrays. Classes allow you to have both data and operations on that data. What you can do is you can make a class that handles vectors of specific data and do operations on them, such as suppose that the vector is a list of students. Some operations you might want to do with that list is you may want to check their GPA and do some math, check the average GPA, check the lowest GPA, get the highest GPA, you know, get the mode, those kind of things. Those could be operations on the data. So your class could be called students GPA records, something like that. Or you can just call the class student records and have multiple vectors. One vector for GPA, one vector for the student's name. Or better yet, you could have a class called student records that has a vector of another class called student. And that student class could have different number variables for different items. And then we can go ahead and put all of those as vectors. Let's go ahead and do that example, actually. I like that example. So remind me and we'll do that example in a minute. But first, let me show you more about this whole private versus public, okay? So, we got our bucket. And the bucket is like a bubble in a way. It's happily controlled. There's no risk of any bad things happening because all of the variables inside of the class. So we have, let's do the height and the area of the triangle. Let's say this is for triangles, okay? So we got two local variables, height and length, and then maybe another variable to compute the area, although we could make that as a return value. So yeah, that'll be good enough. Maybe we have a string for color of the bucket, okay? The operations that we have on the bucket are going to be to get the area, to get the perimeter, and then maybe to get the color, and then maybe to set the height and set the length, okay? And maybe also to get the height and get the length. And that's it, okay? So we want to have a get color or set color, I mean. So here's the thing. All of these variables you want to protect, because if you just let anybody go in there and set the height, suppose they set the height to a negative number. Is that valid at all? Is there such thing as a negative height? Maybe if you think of like an underground like triangle, but we're gonna say that makes no sense. We're gonna say no. We can only have positive values, okay? Because that's what we are setting as a good value, okay? Same thing for the length. We can only have positive length. And for the color, we're only going to allow valid color names. So, you know, red, green, blue, all those colors, white, black, yellow, all those. We're not going to allow potato as a color name because that's not real color, okay? So, disappointment for the potato fans. So, to control that, to make sure that we only get valid data, we are going to sort of have messengers to the bucket. You know, we're going to call them bucket messengers, essentially. These bucket messengers have one job. The job is to go to the outside world and do one of two things. Either take data from the outside world and bring it to the bucket, or vice versa. Take data from the bucket and bring it back to the outside world. I am in the outside world. I am not in the bucket. I am looking at the bucket over there. I am not in that bucket. So I'm like, hey, bucket, please, can you store -5 as the length? And I tell that to the bucket. So the messenger for that, which is called set L, which is right here, is going to come out of the bucket and be like, who summons me? And I'm like, oh, well, technically he comes out to this side because I'm over here. And I'm like, hey, set H, can you please set the height to be -5, please? And he's like, he looks at the height, he's like, that's a negative number. I'm sorry, can't do that. Closest thing I can get to from that is 0. So I'm gonna keep it at 0 or simply not set it. And so set H comes back. And see, there already it stopped from me doing a dumb thing. So I go back again. I'm like, again, hey, I guess I said setL, but setH came out, but whatever. Let's say the setL comes out again. I'm like, hey, can you please set the length to 5? And setL is like, okay. And he goes in here, and he knows it's a valid length, so he goes ahead and sets it to 5. So he's the messenger, okay? He protects you from doing bad things to the code. Sometimes it is useful to be able to see private variables. Sometimes those private variables, it's like a for what do they call it? For your eyes only. No, on a need to know basis. Some variables are like need to know basis, and they're like it's a need to know basis, and you don't need to know kind of thing. Sometimes, in this case, it's actually useful to know what the dimensions of the triangle are. So it is useful to get back height and length. So we want to have a get height and a get length variables, or sorry, functions. Sometimes it is not necessary or even useful to release that kind of data. When is that the case? Sometimes you have internal variables to keep the functionality of the class, such as an ID. You might have a variable called ID counter that increases every time that you make an object of the class, and it could be a static variable. And every time that you increase it, it adds 1 to the class. And that way, every time you make a class, it has a brand new and different ID. It's useless for you to see what that variable is. Other times, it just makes things easier to have some functions inside internally or classes inside. So for those, it doesn't make sense to have a getter. Okay. So what I'm using these with this get and set, which I'll write in bigger letters so you can see better. I sort of put like get length or set height or whatever. These are called accessor functions, the getters. We also call them getters, I guess. So accessors or getters. And then these are called setters, which modify something in the class, or also mutators. Okay? So setters or mutators are going to be the ones that you can change something inside the class, typically something from a private variable, because otherwise you could just access it directly. And getters are ones that access data that's usually private. And if you didn't have a getter, you would not be able to access that data. It will be hidden from you because we are going to make them private. Okay? So those are getters and setters. And like I said, they're the messengers from the bucket, because that bucket is like reinforced steel and you can't see into it. Okay? It's a sealed off environment. Finally, we got get color. So we could get the color, but we can't set it. So you're like, how do we ever set it? Well, we could write a set function, I suppose. But in this case, I was thinking we could do it with a constructor. So that's another thing that we got to talk about. What is a constructor and what is the destructor? Okay. So yes, what shall we do next? Let's go ahead and show you in practice this example with the triangle, and then maybe we do the one for the students. Okay. So let's do that, because I do want to show you UMLs. So we might not have time for the student example today. We'll see. Okay. So let me switch over. And I did have a thing today. Not the other. Yeah, this thing. Perfect. So now we can see the code as we code it. Yes, the bucket gods. When I think of bucket, I think of like a KFC buckets for some reason. I have not eaten KFC in like a year or something, but still. A bucket of chicken. I like KFC, but it makes me sick nowadays. So, too much grease. I do, interestingly enough, I like KFC far more outside of the US. It just tastes better. It blows my mind. In the US, it's like not that great, but outside, it's just like one of the most amazing fast foods ever. Maybe because you're outside and you're just tired of like food, and you're like, you just want some American food, to like go back, safety food as they call it when you're traveling, but still, that could be it too. Comfort food. McDonald's is also better, but I don't like McDonald's here. No, it's okay. But Pizza Hut is it's like a full-out restaurant in most of these places. Like I went to a Pizza Hut in Beijing. It was like a sit-down place with like cutlery and very like fine dining. I was like, oh, okay. I did not expect this when I saw Pizza Hut. But yeah. Anyways. we'll call this our triangle class. Yeah, I have eaten in Mexico. I mean, that's probably where I first ate in my entire life, was in Mexico. I actually had a birthday party in a McDonald's when I was like 3 years old in Mexico or something. Go to the McDonald's in Australia. I've never gone to Australia, but I want to. I have family that lives there. So, low key, I might be able to get like free hotel or something. Okay, all right. So I just went ahead and did the basics, and now for the rest of this, let me actually explain what I'm doing so that you guys don't get lost. So I'm going to write the word public because otherwise everything will be private. And I did show you the error last time, but I guess I can try to show you again. This should compile probably. I think even if there's no body, it'll compile just for sake of showing you something. No, oh well, this needs to get int. Okay, now it'll compile. Yeah, but here's the thing: if I try to make an object of this class, and then I try to do t.h gets 5 or 4. This is going to cause problems. It says that it is private. Okay? So basically, this is a sign that you cannot access this variable. Is this fully secure? Absolutely not. I will show you how to crack this security in a way. In fact, I have a, right now we're doing all of the assignments by other people. But I had like my own set of assignments that I made, and I had a really cool assignment for this, like called Crack the Vault, where you would hack into private variables. It's really cool, but we're doing group assignments now, so it's okay. I might show you the assignment sometime, even if you're curious. Maybe do it as an extra credit. That could do that. That could be cool. Yeah, that might work. I could do that as an extra credit assignment. So maybe I'll do that. But yeah. So essentially, there are ways of cracking this. Again, it's not meant to be safe. It's more of meant to protect me when I'm trying to compile code and doing things I shouldn't, like accessing private variables. That's really what it's there for. So we get a compile error. By no means is this actually secure, okay? Why don't we do your assignments instead? Because we sort of well, first of all, that assignment I've done twice already, so I'm assuming that the solution is in the internet somewhere. Although I try very hard not to. And two, because it's good for, I guess, to change things, breath of fresh air kind of thing, I guess. And here we have different people, so you get to see different tastes of code, from different coders. You don't get just one sort of like, style, which I think, I mean, obviously I want to say my coding style is nice. Not this kind, but at least the one that I do when I do the actual assignments. But, it is good to see a diverse sort of ideas. But yes, we can't really be using the same stuff every time too. Yeah, so that's one of the bigger things, But okay, so that's the warning that you get. So if you ever see this, it means you're trying to access a private variable, okay? Which means you need to do a getter or a setter, or you make the variable public, okay? Those are the solutions, the 3 solutions. Obviously, 2 out of the 3 are going to be knocked out by some sort of assignment requirement or something, so it'll really be stuck to just one. Yeah, that'll be interesting to see. Okay. So anyways, how to make it public is very easy. You just put the word public and you put a colon. Again, C++ does not care at all about spacing. So my personal style is, some people just like to make it flush. I like to put a little space. It just triggers me if I see it flush. Sometimes I'll do 2 spaces, but I do like to make all those modifiers on the same line. So if you ever want to make it private again, you can just do that. And you can go back and forth. I could, why would you do this? I don't know. But you could do this like 50,000 times in a row. And the code is like, okay. Compiler probably actually removes the extra ones. So, okay. So now we have 3 private variables and 3 public variables. Or sorry, functions. By the way, that's what you typically do. Variables are private, functions are public. But as I said, there are some cases where it is useful to have some private functions that are solely for internal usage. We'll see a good example of that at the end of the semester when we talk about recursion and we talk about linked list, and we do like a recursive linked list print, and we'll have like an internal function for that. But publicly, it'll have a different function. That only job is basically to call the other function. So yes, it's weird. We'll see an example of that. So don't worry. But for now, most of the time, pretty much every function will be public, and pretty much most of the variables will be private. Although some variables are good to be public. Basically, you really only want to don't go hardcore and just like accept the fact that everything must be private. It's more of like, if the variable should have some type of data protection, as in like you don't want specific values to go in there and you only want a specific range of numbers, then make it private. If you don't care what's in that variable, then make it public. That's kind of a good rule of thumb. There's kind of an exception to that, and the exception is this. You typically do have to do some sort of error checking, okay? And this is, I'm sort of trying to talk, I mean, most of the assignments kind of should hopefully tell you what to make what private and public. This is more of advice in general when you're coding for yourself. A good advantage of making something private is that if you control the data that is going in there to be a specific range, that's the only spot in the code that you need to error check for that variable. If you don't control the data that goes into that variable, then every time that you are accessing the variable, you may need to error check to make sure that there's no invalid data. Because at any time in the program, it could have been changed. So it adds a lot of extra checks that's necessary code. So it's like the idea of sanitizing your input. You sanitize these variables when they first come into you. That way, you never have to check for errors again in the rest of the code, because there's no way that somebody could change them unless they do malicious things, which in this case, screw them, let them crash the program. So that's sort of the good sort of rule of thumb about why make something private like that. If you make it public, then basically assume the worst, that any time in the code they try to change it to something really bad. And again, not because they maliciously, but because you left it public so they may not know any better. Okay, so yeah, such is life. So okay, so we got our get color, we got get height, and we got get length. We are also going to do setters. Your setters are typically void functions, but they will contain a parameter, and that parameter is going to be the value that you're setting. Typically, you want to make it a const because it's something that is only supposed to set something, not to potentially change it. So typically, you see the word const being used in there, but also here. Or sorry, no, not on this one, just on that one there. Okay. Where you want to set that one to is on these ones. These two functions, only job is to get a private variable and return it. So these, you don't want to accidentally modify the variable. So putting const in front of them like that is a mini protection to protect you from accidentally doing something like L gets 5 or something, 4. Okay, that's what const does here. It protects. It makes it sort of a read-only function. Okay, this const makes this a read-only variable, but not function, and that's good because this function actually has to set one of the private variables, which is very easy to do. You just go ahead and do that. That's one way to do this code. Another way to do that is you put a colon here, and then you put the variable name. Oh wait, no. I don't think you can do that if it's not a constructor. Can you? I don't think so. I think you'll include the constructor. So never mind that. You might be able to, but I'm not sure. Yeah, so ignore what I said in a second. Okay, so these are your setters. As you can see, they're very short, single line of code. However, this is where you would do your checks. So you could do something like if length is less than or equal to 0, or I guess less than 1, then go ahead and basically see out invalid length, setting to 0 or something. Or you can just not set it to anything too. Let's just do that. So we'll just say invalid length and then not set it to anything. What's wrong with this code? Why? Oh, I see. I forgot the code. Okay, so this is a very, very small example of a check that you would do. Now we have a couple questions here. Is making the variable private like an equivalent of making it a const? Well, it's equivalent in the sense that the consts are there to protect your code. Not equivalent in actual usage, right? Because private doesn't allow you to see the variable outside the class. So here's the thing. Notice here that these variables are private, but I'm still able to access them in the functions because these are member functions. I can't access it here because that will not compile. This line of code will not compile, but these lines of code will compile because these are member functions. So remember, private variables cannot be accessed outside of the class. They can only be accessed inside of the class. And by that I'm saying only member functions can access them. That's kind of the rule of thumb. Public variables work like structs do. You can access the variable inside the class, like privates, but you can also access it outside the class. So you can do like the t.h, okay? So that's the difference between private and public. So anyways, coming back to this, we went ahead and did our setters. The getters are very easy to do too. All you gotta do is say return L, and then you're done. This one up here, we'll do it in here because we're running short on time. But all of these functions could be written outside, kind of how I did this here, okay? You can do the same thing. I typically in class will do them inside because it's faster. But sometimes I'll move them outside when things get crowded and I need space. But just wanted to make you aware of that. Okay, so we got a getter, we got a setter. We still need to do the color one. So here, how about this? We'll do one of them outside. We'll do the color one outside. So we'll do string get color. So we got to add in the class name, which is called triangle. Get color. And I'm going to do it in a single line because it's starting to get really big and it cuts off the code. We're just going to return color. Okay. Did we define the color variable? We did. And finally, we're going to do one more thing here. We're going to do what's known as a constructor. Okay. What is a constructor? Whenever you instantiate a class, or whenever you create an object of a class, sometimes it is nice to initialize the class. Just like when you create a variable. You know, when I create a variable, like if I say int x gets 45, not only am I declaring a variable x, but I'm also initializing it. Why do it in the same line of code? Because it's not a good idea to declare variables and not initialize them because there's garbage in them. And so it is a very, very sort of nice thing to do. The only time you don't do that is if you're going to read in the variable from somewhere or throwing in a loop or something, right? Same thing with objects. It's a nice thing if we could initialize them. What kind of things could we initialize here? Well, we can set the height and the length to be 0, and we can set the color to be some valid color, or take that color from the user at creation time. And then once it's set, it can never change again. So that might be a good reason to make it private. We can get the color, but we can't ever change it. Once you set the color, no changing allowed for the color. Okay, just an implementation decision we made. And so constructors have that usage. They always run when the object is first created. By the way, there's also destructors. Those run when the object goes out of scope, which is basically when the object is never used again. So basically, if the object is in a function, when the function ends, that object gets destroyed because it's inaccessible anymore. So in this case, because in main we are creating the triangle object, when main ends and it sees the return 0 or just ends the function, that object goes out of scope and the destructor runs. When we talk about dynamic memory allocation, that's a very powerful thing because if we do dynamic memory, we will have memory leaks if we don't delete the memory after we're done with it. So the destructor runs when it goes out of scope, and that can do your cleanup per se. How do you make a destructor and how do you make a constructor is very easy. It's a different kind of function because destructors are neither value returning nor void functions. They're neither of those. They are sort of like a weird sort of own category. And how you actually declare them is you just type in the function name, or sorry, the class name. Bam, you just created a constructor. Destructor is the same thing, except you add a little tilde at the front of it. Bam, you just created the destructor. But in this case, there's really nothing to do in the destructor, so we're just gonna say goodbye. Let me show you, for the destructor, why not, how you would actually declare the destructor outside the class, because that one looks a little bit weird. It's still the same system, but there's no return value and there's no void function, so you don't put either of those. All you put is triangle and then the destructor. See that? So it looks a little bit weird because there's no return value, okay? And if it was a constructor, it'd be the same thing, you just remove the curly bracket. But that one I'm gonna do in here because I wanna do inline stuff. Okay, so for the color, I'm gonna show you the other thing I was gonna show you before, but then I realized it was a constructor, is another way of initializing variables. One way is, yeah, sure, I can do something like, you know, L gets 0, but there's a cooler way. You put a colon, and then you put the variable name like it was a function, and then you put parentheses, and then you put whatever you want to initialize it with in there. And then you comma separate them for multiples. So let's say that we require the user to pass in a color. So we're going to say string color, we'll call it string C. And then we're going to make it a default parameter. So if they don't pass a color, we're going to make the default to be red. Okay? And so now, here in color, we can pass C, which will be by default red, or it could be something else. Now, we're not error checking, so technically we should probably error check. But, you know, I'm kind of just going to, in fact, yeah, I'm going to just leave it like that. We can do the same thing with the other variables. So we can have length and width here so that people could pass a specific measurement for each of them. But otherwise, we will set them to 0, length and height. And then go ahead and initialize them like that. So we got length. We're gonna naming issues here. So we'll make the length and height. I don't want to write confusing code with the scope rest operators here. So length. Oh, hold on. Let me put it on the next line so it doesn't cut it off. And then height. Can't see. Oh, yeah, well, I'll fix it. See what? See that? No, the destructors is off the bottom of the screen. Oh, okay. I'll scroll over to that. So here is the destructor definition. Basically, you are putting in the class name, scope resolution operator, and then the destructor name, which happens to be the same name as the class name, but a curly bracket, okay? And if it was a constructor, you would just get rid of this thing, okay? And then you just put the body, so there you go. So yeah, see, this is why I write bad looking code here, because I want to make it as compressed as possible. So let me go ahead and do that right now. Let's also put these on the same line, and then let's put these on the same line. In fact, we technically don't even need the these things. Yeah. Okay. There we go. Now we made it more compressed and it's a little bit better off. Okay. So yeah. So we got length, color, and height. Okay, and so there we go. Now we got everything in the same screen. Of course, don't code like this. Code properly, like with space. But here I'm doing it so it fits in the screen. So the only thing here is we kind of want to check the color, you know. So length and height, that's fine. We're not really checking the color, so yes, ideally we would want to do that in the constructor like properly, you know. Maybe we can put in like get rid of the color here and then have an if statement, you know. I'm just gonna check it against one color, but you get the idea. So if C is equal to red, or C is equal to white, and so on, basically, then you can go ahead and say color gets C. Otherwise, color gets red. Okay, so you would want to do the error checking here. And there we go. That is our full class. Let's see if we have any typos. No typos. Cool. Let me turn off this thing. So let me switch over back so we don't need to see the iPad anymore. There we go. And so we run it, and all we see is goodbye, because that's when the destructor runs. Maybe we can put a little hello in the constructor. So cout hello. Now we should see a hello and a goodbye. Okay, cool. But let's go ahead and get the area of a rectangle. So create a function to get the area. So maybe we do int area, and then that's just going to be return length times height times 0.5. And then maybe let's do a perimeter. As you can see, we don't need to pass any parameters because we have them all as local variables, so that's great. So what's the perimeter of a triangle? That is going to be the length plus, oh man, we got to do Pythagorean Theorem here. Because it's the length times length squared plus height squared, and then take the square root of that, and that's going to get us the diagonal, and then multiply that times 2. So, okay. All right. I think that's the way you do it. I mean, there might be a shorter formula, but that's just like what I think. So here, let's include CMath. Yeah, okay. So that is going to be, so maybe that one will require nicer code. So let's see, length, so it's going to be, okay, so length squared, so length times length, plus height squared, so height times height, and then we are going to take the square root of that, and that's going to get us a diagonal. So we're going to multiply that times 2 to get both diagonals, and then we're going to add the base, which is length. Okay? And that should give us the right formula. Okay, so now we're going to say t times perimeter, or sorry, t perimeter, and then also let's get the area t. So cout p for perimeter, and then cout the same thing but area. Here, save space, we'll do everything on the same line. There, kind of squished together, but whatever. Okay. P00. So right now the initial values are 0, 0. So let's make it more exciting. Let's do like a 2 by 3. So that is going to be a white, because we did check for white, and then 2 by 3. We got the area is 9 and the perimeter is 9. How about we confirm that? So let's see. So we have 2 by 3. Okay, so the area would be 2 times 3 is 6 divided by 2 should be equal to 3. We got 9. Oh, did we length times height? So 2 times 3 is 6. Why did we get that? That does not look right. Okay, let's go back. We get the length here. We get the height here. Area. Length times height times 0.5. Why is that giving me the wrong? Oh, sorry. I did not. I was calling perimeter twice because I copied and pasted. I did not call the area. Yeah. Thank you. Good catch. Well, I caught it first, but good catch still. All right. So there we go. Now we get 3. So I was like, what? Okay. So let's see if the area worked. So my thought process for this is we split it into 2 triangles. Okay. So by splitting it into 2 triangles, I screwed that up. Yeah. So technically it's length divided by 2. So I screwed that up. So actually, it would be technically length divided by 2. So it would be length divided by 2 squared. So let me fix that. Because here's what I'm thinking. What we need to do is, this is technically length divided by 2 and length divided by 2. Okay? And then this is height. So Pythagorean Theorem tells us that a squared plus b squared is equal to c squared, right? So a squared plus b squared is equal to c squared. And so if we want to figure out what c is, we just take the square root of both sides, which gets us c, right? And so a squared is nothing more than just L divided by 2, and then b squared. And then b squared is just height squared. And then the square root of that. So I screwed up because I did not take the divided by 2 part. So if we want to, what I really should have done is I should have done L squared divided by 4. So I just got to add in a divided by 4 there. So let me just add a 0.25 to the multiplication. And that is why it's useful to draw things out. So let me do a 0.25 times this. So yeah, because we still got our L squares here, we got the quarter here, and then to that we are adding in the squared. So yeah, so that should give us the right answer this time. So 8. Now this is probably, we probably need to make this a double so that we get more accuracy. Okay, so we got 8.32 something. So is that correct? I'm pretty sure it is, but I don't know. You guys can go test it on your own time if that's correct, but I'm pretty sure that should be good. Basically, half of 3. Here, we can probably do an, this is 2, so the half of that will be 1/2, plus 1/2, plus times 1/2 squared, so that's really just 1/4. And then 1/4 times 3 would be 3/4. Well, no, 1/4 plus 9, and then so yeah, that seems kind of big, but I don't know. You guys can go and check it out. So check it out and let me know if I did the right computation for that. Okay. Oh, did it now? Oh yeah, I did. But why am I getting the perimeter to be, oh, because I did double. Yeah, you're right. But still, the perimeter is the one that we're trying to figure out. So I think that that's the right perimeter, but you guys can go and check that on your own times and see if we got things right. Technically speaking, this would only work for an equilateral triangle, because if it's tilted to one side, then we can't perfectly divide by half the thing, I believe. You know what I'm saying? So like, it'll work for like a nice triangle like this, but if you do it like this, then it's not going to work. Okay, because this is where the right angle would be, and so we can't really split this into 2. So it's not going to work for all kind of triangles. It's only going to work for the equilateral triangle. If you want to do it for this triangle, you need to use trigonometry to get those angles. I don't remember the actual thing for that. It's like it's a mixture of cosine and sine and whatnot. Maybe tangent is involved. I don't remember. But you can do it based on the angles. But then you need to know the angles at least. Of course, all the angles should always add to 180, if I remember correctly. Yes, you will need a mixture of the angles, okay? So that's kind of just, I mean, because what you would do is, you know, you could do the Pythagorean to get this part of that, if you know the height, you know, but to get this piece and this piece, what you need to know is you need to know one of these two angles. I think if you know this angle and you knew this angle, you can get the third angles. You need two out of the three angles, I believe, but you know, it's been a while since I did geometry. So yes, but anyways, for the equilateral triangle, the one that's like perfectly straight here, then this formula will work, which is good enough for this class, okay? So any questions? Otherwise, the last thing I want to show you is the UML diagrams, because that will be useful for doing the second assignment, because I was looking at the assignment and I think you need to do that. So UML diagrams. How do I show you that in an easy, fast way? Let's just try and go for it. So universal modeling language is a way to express your classes to your peers. So like if you're trying to come up with a really good idea for a class, like you know, you're going to make this triangle class, for example. One thing you could do is you could just code it and show it to them, but that's a lot of work. Another thing you could do is you could kind of just sort of put some pseudocode together. But a better way to do this is with a UML diagram. The UML diagram allows you to express your class in terms of function names, the parameters the functions require, the class variables, and whether something is public or private. And then you can deliver that to a developer who can then actually create the class. And then you can, of course, put descriptions next to each of the functions so they can know more about what they do. So let's go ahead and do that with the class that we just made. Okay? So the class that we just made, here, let me get rid of the terminal. Here we go. Has a couple of functions, right? First of all, what we're going to do is we're going to do a little square. Oh, failed. Okay, and now let me just move that square into the screen there. And the first thing we're going to do on the top is we're going to put the class name. So that is going to be triangle, okay? Then we are going to list all of the variables, okay? And so if the variable is public, which we don't really have any, we would put a plus symbol after that. If the variable is private, then we're going to put a little minus symbol. So in this case, we got 3 private variables. And that's what the minus and the plus signify. So the plus is public and the minus is private, okay? And so in this case, we have color, height, and length. So the way we're going to write it is we're going to write the name of the variable first. So color, height, and length. Then we're going to put a colon, and then we're going to put the return type, which is a string, or not the return type, and this is the data type. So it would be integers, integer, and string, okay? If we had an array, we could do something like string square or something, okay? Then, after we finish listing all of our variables, both public and private, then we're going to list all of the functions. The way we list the functions is, again, we put a plus or a minus in the case that they're public or private. So in this case, all the functions we have are public. You should, by the way, tip here I never really said, but we'll talk more later on. Always make your constructors and destructors public. That's just a thing you should do. We'll talk about the reason why in a future class, okay? But don't try to make them private. Bad things will happen. So I'm not going to list all the functions because we are running short on time here. So, but I'll give you a couple. So let's say we're putting in the getColor function. So you put getColor. This one has no parameters, so we won't put any parameters. We put a colon, and then we put the return type, which in this case is string. Let's do an example that has parameters. So let's go ahead and do set length. Okay. So we will do set L. And then in the parentheses here, we would put in what it takes. So const int, and that's it. You could put the ampersand to say pass by reference. That's okay. And then this set is void function. Okay, and that's pretty much what you do. Make sure you also list your constructor in here as well. But this is what is known as a universal modeling language diagram. And it's an easy, fast, and compressed way of expressing how to build the class. What it doesn't say is how to implement these functions. Like, how do I actually implement get color? How do I implement set length? Like, for example, in set length, I want to make sure the length is not negative. It doesn't say anything about that. It just says that there needs to be a function here, and then in additional documentation would describe the description of what that actually implies, like what kind of error checking you need to do, etc., etc. So when you see the UML diagram of a class, and I think in assignment 2, that's what it is. This is what they're trying to tell you is this is the function you got to write, and then if there are specific specifications about like what each function needs to do, then go ahead and implement those. If not, then just get the function implemented as to the best of your abilities based on what the description says in the PDF. Okay? So that is the end of the class. I guess we started like a minute later, so that's okay that we finished a minute later. So yes. Questions? I'll just idle here. And by the way, as a reminder, there will be a video next Tuesday, but we won't have live stream because I'll be recording it on Monday, and that's technically Labor Day. I thought you mentioned for assignment 2 it will be like a week later, not next week. I'll check. I actually need to bring that up with all of the instructors, because some of the classes don't have class because they have Monday class, and that's gonna put us out of sync. So I don't know, because of that they're gonna change the deadline. So I will talk with them about that. But all the deadlines are we're trying to make them unified. So, you know, because I've had like 2 people send me messages like if I could extend the assignment, and if it was my assignments, I could do whatever I want. But since these are full class thing, then we're keeping it unified. But like I said, I need to bring up the fact that we have a holiday and how that's going to affect the timeline of things, because otherwise one class is 1 day behind, another class is not. We won't be behind, but others will be. So yeah. So we'll talk about that. So if that makes this deadline change, then yes, I will change it. But it's not up to me. Anything else? All right then. I guess nobody has anything else. So in that case, I hope you guys have a good weekend, I guess, since it's Wednesday, but it's the last time I'll see you. So no problem. I appreciate your guys' questions. I'm glad that you guys are here watching too, because it can get pretty boring to just talk to no one. Like, I will do my best to get to the next class without anybody. But yeah. All right then. Well, I'll see you guys later. I am on Discord. I had some people message me asking me when they can message me. You can message me at any time. I might not respond immediately, but you can message me and then I'll get to it whenever I get to it. So I'm usually awake until pretty late, so feel free. I was helping people last night, like late night, so please feel free to message me, and then I'll get to you as soon as I can. I actually entertain myself when I'm eating by responding to people, because it, you know, multitask. Otherwise, I don't like sitting there just eating. So I do appreciate your guys' questions. It gives me something to do. So yes. All right then. I'll see you guys. Stay safe.